Hello, everyone. Thank you for joining this virtual session here at the Embedded Linux Conference in North America. And today, I'm here to talk about PipeWire, which is this new multimedia services for Linux that is emerging and is gaining more popularity nowadays, and how it's ready for the automotive world. I'm going to split this conference into two parts. On the first one, I'm going to talk about how PipeWire works, what is it, what advantages does it have compared to other multimedia services. And then on the second part, I'm going to focus more on embedded and automotive and how PipeWire was adopted by one of our clients last year. The client is Automotive Grade Linux, so how it was adopted as their main core multimedia service. But before moving on, I'm just going to do a quick introduction to myself. So hi there, I'm Julian, and I am a Spanish multimedia software developer. I'm part of the multimedia team at Collabora. I've been working, I joined the company quite recently. I joined almost a year and a half ago, and since I joined the company, I basically worked full-time on PipeWire and therefore WirePlumber, the session manager. So that being said, let's start. So what is PipeWire? What is technology that everybody's talking about nowadays? PipeWire, as I said before, is essentially a fresh multimedia service for Linux that was originally meant to handle only video devices. In fact, the original name of the project was PulseAudio, but then it evolved and it became more a generic multimedia services that can handle both video and audio devices. So with PipeWire, you can basically capture video buffers from cameras or graphic sources such as Wayland, for example, if you are recording your desktop, or OpenGL or Vulkan if you're running a graphics application on your desktop. But you can also do audio and capture playback. So you can basically capture buffers from the microphone of your computer, and you can basically play music also, or play any kind of audio in the speakers of your laptop. So this is like basically the whole, generic concept of PipeWire. The idea is for applications to connect to this service, which is basically a server or a daemon. And basically that service handles these devices automatically for you, and applications, they just need to worry about, sending or receiving buffers in a specific format, and that's it. So they don't need to worry about configuring devices and anything like that. So why do we need PipeWire nowadays? We have we have PulseAudio and we have Jack. So PulseAudio nowadays is more like a generic audio services that handles audio devices on your desktop. For example, if you plug a headphone, so it's gonna stop using the speakers of the laptop and it's gonna use basically your headphones. And then we have like Jack audio server, which is more focused on professional and low latency audio playback. So why do we need an extra one, right? Well, one of the main problems that PipeWire wants to solve is to unify basically PulseAudio and Jack servers. It wants to basically replace them, and basically your computer will just run one audio server that handles all of that, simplifying a lot the Linux multimedia stack. Because at the moment it's quite complex. So if you want to do both things, you have to run PulseAudio and you have to run also Jack. And these two servers, they have to basically send debug messages, for example, to reserve a device, because a device can only be used by one of the servers. So there's basically debug messages going around. There's more complexity, it's slower, it's hard to maintain, it's hard to understand, and it's also hard for the applications to know which one they should use. So all of that is hard to maintain, and it's way much better and simple to have just one audio server that handles all of that. Now, another thing that PipeWire solves is the permissions, because it supports containers like Flatpak, and it doesn't rely on group permissions such as the famous audio and video Linux groups to basically know if it can access the video devices or the audio devices. No, PipeWire basically asks the container, Flatpak or Wayland, if he can have access to the video or audio devices, and based on that, is basically going to give you permissions or not. So this is very important nowadays, and PulseAudio and Jack audio server don't do that. So in terms of security, PipeWire is way, way much better. Now, PipeWire is also very, very low latency, so it can handle very small buffer sizes of up to 32 samples, which is about 1-2 milliseconds of latency. And it's also very, very flexible, because it provides an API for users to write their own external session manager, and you can adapt basically PipeWire to any use cases, because the session manager tells PipeWire how to behave, when a multimedia application connects to the daemon. We're going to talk about the session manager more like later in the session. But for now, let's just have a look at the Linux multimedia stack if we run, the PipeWire server on our computer. So the PipeWire server can be seen like as a middle layer between the kernel and the applications. And as you can see here, there's plenty of example applications. These applications, they basically connect to the PipeWire nodes, which are like processing elements. And these nodes, they basically do all the format conversion, the mixing, and all of that. And then send or receive buffers to the multimedia device. So for example, if you want to screen capture our desktop, basically the application would connect to the Wayland source to basically receive buffers. And then basically record them. Or, for example, if you want to play multimedia, like for example, you want to play music with a music player, that music player would connect to the audio sync processing element of PipeWire, and they would play. And for example, if many applications want to use a specific device, PipeWire handles all of that. So for example, 2 applications could connect to the same processing element, and again, all the format and device setting up and checking they're busy or not. This is all done automatically by PipeWire. Applications, they don't need to worry about that, which makes all the setup much, much, much easier. Another thing is, as you can see on the top right corner, the PipeWire Session Manager is also an application that is connected to PipeWire, and basically it controls PipeWire. It tells them what device to use in case there's multiple, cameras or multiple speakers. So basically the Session Manager specifies a policy logic to handle and create all the links based on that logic. Which makes PipeWire very flexible, and it makes PipeWire to be adaptable to any use cases. So if I want to use PipeWire on my computer, do I need to change all my multimedia applications? Well, no, because there's some compatibility. There's compatibility APIs built on top of PipeWire. So, for example, also applications, they can use the PipeWire PCM plugin, which internally creates those PipeWire nodes and connects to PipeWire and sends the buffers to PipeWire instead of also. And the same for PulseAudio and Jack, because there's replacement for libpulse and libjack. So applications, they don't need to change. Eventually you want them to change and use the PipeWire API, but it's something that doesn't need to do quickly. You can use these compatibility APIs and everything will work fine. We're going to see an example of this, for example, in the demonstration video that I'm going to do at the end of this conference. Now, the architecture and design of PipeWire is very similar to most of the open source projects. So it has modules, and each module implement a different driver. For example, we have a module for the video for Linux drivers. Then we have a module for the ALSA drivers. Then we have a module for Bluetooth, for example, and then we have, each module has like plugins, and these plugins implement different functionality on these modules. So for example, for audio, we have plugins to do audio conversion or audio mixing, and for video, we have also video conversion. So it's, as you can see, it's very similar to GStreamer. So because it's graph-based, so we have nodes instead of elements, which are basically the ones charged to process data. Then we have ports, which are like pads, and basically ports are the connections between the nodes, and they have a specific capability. They have the buffers, they have a specific data. And then there's also links, which in PipeWire are objects. Now, another important thing is like PulseAudio PipeWire is multi-processed. So it's basically a daemon that runs in the background, and then clients connect to it. And the daemon basically is charged to process most of the data, even though nodes can also run in the clients, which can be very useful. For example, we have slow nodes that we don't want to install the PipeWire daemon, and we want to run them on the clients. This is very useful, for example, for Bluetooth. And again, another example of another process is the external session manager, which is a different process that is connected to PipeWire, and it tells him how to behave. So yeah, it's multi-process, and the communication between the processes is via a protocol with sockets. It's also another very, very interesting feature about PipeWire is that it's also fully based on its internal and simple plugin API library. So it doesn't have any dependencies, so it only depends on that SPA library, which is already included inside the project. And it's an extremely simple and lightweight generic purpose multimedia library. So with that library, you can basically do audio mixing, you can do audio conversion or video conversion, but very, very simple. And it also has like some generic data structures like arrays or like lists or hash tables, but very, very simple, because most of the library is a header-only C library. And again, it's that doesn't depend on any dependencies. So it's very, very different if you are familiar to GLib and GStreamer libraries. Now, thanks to that library and its static code design approach, because there's almost no mallocs, so you grab for the PipeWire project, you will hardly see any malloc. Thanks to all of that, the performance is very, very impressive. It also uses modern Linux APIs such as memfd and DMA buff to zero copy buffers from the devices, and it also uses eventfd and timerfd for waking up processes and for scheduling. So thanks to that, PipeWire it's considered low CPU usage and low latency real-time capable. In fact, if we have a look at the performance, we can see here some graphs comparing it against PulseAudio. Each graph will basically show you the performance, the CPU usage with different buffer sizes. So, for example, we have big buffer sizes of 8,192 samples, which the performance is mostly similar to PulseAudio when trying to do a playback of a file. But then, as the buffer size reduces, the performance of PipeWire doesn't change too much, whereas in PulseAudio increases completely. So, for example, for small buffers of 62 samples, the CPU usage on PipeWire is only 0.03%, which is very impressive. And, for example, if you do a mixing of 2 channels of buffers of 512 samples, the performance is just 0.007% compared to PulseAudio, which is only 0.2% of CPU usage. Now, also another thing to note is that PipeWire handles buffer sizes of even smaller than 62 samples, so you can handle 32 sample buffers. and PulseAudio cannot handle that. There's errors, there's underrun errors when you try to use small buffers like that. All these performance is published on the wiki of the PipeWire project. You can see it in there, and the hardware this has been tested is basically an Intel Core i7 3.4 gigahertz. Now, if you compare the CPU usage against Jack, we can see that it's mostly similar, but it's better as you use smaller buffers. So, for example, for Jack, the performance of 128 buffer samples, it's 0.017%, whereas in PipeWire is 0.017%, whereas in Jack is 0.026% when running one client. And when we run 8 Jack clients, the performance difference is actually even bigger. Again, this was testing the same hardware, and you can see more results if you're interested in performance in the performance wiki page of the PipeWire project. And again, if you use buffer size of 32 samples, Jack underruns and fails, whereas PipeWire works. If you really want to achieve extremely low latency of 1 or 2 milliseconds. Now, security in PipeWire is also done correctly. Like, as I said, it uses containers instead of relying on user groups. And basically, the session manager grants permissions to applications. So, and every part of the graph, every node on PipeWire can be made visible to some applications or can be hidden to some other applications. So the applications can see an entire different graph when they connect to PipeWire. And there's 3 kinds of permissions. So there's read, write, and execute. Read means that you can see the node and you can capture buffers from it. Write means that you can write buffers from the node and you can do playback. And execute allows applications to basically execute methods on these objects. So, for example, they can configure the node to basically use a specific format and stuff like that. Okay, so now let's move on the external session manager. So a very interesting thing is that the external session manager, it's not included in the PipeWire project. There's only one example of it, which is mostly used for testing, but there's no reference implementation of a proper session manager. So the session manager it basically creates and configures devices to emit new nodes. It set up nodes, it set up the number of ports, the number of formats. It creates links based on its policy logic when a client connects. It grants security and access controls to clients. And it's also launched by the PipeWire demo at startup. If you run PipeWire without a session manager, it doesn't do anything. It's just going to be there waiting for you to tell him what to do. So the application that has full control of PipeWire is actually a session manager. So the current status of PipeWire is 0.3.5 version was released last month in May 2020, and it was shipped and distributed in Fedora 32. That release improved a lot of issues, so plenty of Jack applications now they are already working with PipeWire. The same for PulseAudio. Bluetooth is starting to be fully supported, even though it needs more testing. The MIDI interface works. It's planning to replace PulseAudio soon. Jack is going to wait a little bit more. Video capture works fine from video for Linux devices, and you can even do screencasting with Western, GNOME Shell, and Wayland roots. All of that is supported. And it was adopted by AGL, as I said, Automotive Grade Linux, as the core audio framework last year. So who started this project? So the author is Wim Tymans. He's a well-known old GStreamer developer and ex-maintainer. The project is sponsored by Red Hat. It's embraced by PulseAudio developers because it's seen as the next generation of PulseAudio. And it's also welcomed by us and Jack developers. The license of the project is MIT. Before moving on to the second part, now I'm gonna this is a small example of a small contribution I have made in PipeWire. It is possible now to generate a graph with all the nodes, links, and ports that the daemon has by just running the PipeWire.tool. There's several options. You can show basically all the objects, you can only show the linked object, and you can show all the properties of the objects, which is very, very easy to debug. So with that, it's much better now. If you want to become a PipeWire developer, it's actually much easier to contribute. Again, this tool, I'm going to show you an example of this tool in the video demonstration at the end of this session. Okay, now let's move on to the second part. So PipeWire in the automotive industry. Why PipeWire suits perfectly the automotive industry and not other audio servers? Well, the problem is that device handling in connected cars is very complex. So, in a speaker you have basically one microphone, two speakers, the left and right speakers, and a camera, and that's it. You always have one camera, one microphone, or two speakers. The most complex logic you can achieve on a laptop, for example, is what if you connect, a headset. You basically have to stop playing audio on the speakers and you have to use a headset. That's mostly the only logic you have to do. But in our car, it's way, way much more complex because there's plenty of speakers and cameras. So, for example, there's speakers on the front, there's speakers on the back. Like, for example, the GPS and all of that probably want to just use the front speakers while the music, when you're playing the radio and all of that, you want to use all of the speakers, and emergency, you want to use all the speakers. There's also, you can also connect a Bluetooth and you can speak on the phone while doing all of that. And then there's multiple audio stream radio emergency navigation communication that can happen all at the same time. And on top of that, there's also different cameras. So, for example, if you are, parking, you are going backwards, you have to use the back camera. But if the car moves forward, you want to use the front camera. And this also, all these handling is very complex. So, how do we handle all of that? The solution is a PipeWire with a custom and flexible external session manager that allows basically the users define their own policy logic to know what device going to use based on what the connected car or the system is doing. And with PipeWire that's possible because with PipeWire you can do custom policy logic, you can do custom hardware pipelines, hardware control abstraction, and on top of that it drives security. So as I said before, there's no default reference implementation of a session manager for PipeWire at the moment. And this is why here at Collabora we had the motivation to write the first external session manager for PipeWire, which is called the WirePlumber. WirePlumber was originally planned for embedded only to solve the automotive case we had last year, but it evolved and now it's a generic and fully featured session manager for both embedded and desktop. Against PipeWire, so WirePlumber is based on the object to support bindings in other languages such as Rust, Python, or Lua. And this is because we want the users to be able to define, the policy logic very quickly without needing to write complex low-level C code. So WirePlumber introduces new objects to make that much easier. So it introduces the concept of an endpoint, which is basically an object that handles PipeWire nodes. Think of it like the end part of a graph, more like a bean with a lot of nodes, and that they have a specific logic. So, for example, there is the audio software DSP endpoint, that basically handles all the mixing and of different audio streams, and then, for example, the simple node endpoint that basically wraps a node into an endpoint. Now we have streams, which are basically connection point of our endpoint. Streams can be seen more like a port of an endpoint because they are used to link endpoints. And then there is the session, which is basically a set of endpoints. So we have, for example, the video session that only has video endpoints and the audio session that has audio endpoints. And session is also much easier to handle permissions. Users obviously can create new sessions. So to have a better idea of this, so you can see here an example of a software DSP endpoint. So on the right we have obviously the software DSP endpoint, and on the left we have the client endpoint. And the client is basically a music application that just wants to play music on the speakers of your laptop. So it's going to basically connect to the music stream of the laptop speakers endpoint. But for example, if another application, for example, your desktop manager wants to send a notification that, for example, you have received a new email, it would connect to the notification endpoint, and again, all the mixing is done internally in the endpoint. So that defining the policy logic is much easier. But again, and let's say, for example, in embedded and let's say you're running PipeWire in a car. So for example, you have the media player and you want to play music. For example, you want to play radio and you want to use the car speakers. So you can basically connect the for example, the speakers of the car to the alpha stream, and then the notification would be connected to a different speaker, so for example the front speaker for emergency. And you can wrap all of this logic into an endpoint, and basically defining the logic for desktop and for embedded, it would be the same, because the implementation of the endpoint is not exposed to, it's not important for when linking endpoints. So yeah. In terms of the design of WirePlumber, WirePlumber is essentially a library, a libWirePlumber.so, that provides an API that makes easy writing WirePlumber modules and even other session managers. So WirePlumber is essentially an executable that loads the modules written using that library that provides, functionality. And that's it. But you can, if you want to use your own executable, you just can use the WirePlumber library and do all your logic as you want. So it's modular. So some example of WirePlumber modules are the monitor module, which basically monitor device and creates nodes when enabled. Then we have the client permissions, that base module that grants permissions to clients when connected. It has a config endpoint, which basically creates different endpoints per node based on configuration files. And we have also the config policy module, which basically links endpoints based on configuration files. And finally, we have, we plan to, right now it's not included, but we plan to add bindings support. So one example would be writing a module in WirePlumber that interprets Lua files for quick and easy custom policies. So this can be very useful for automotive and embedded cases, because Lua is very nice for writing configuration files. But for example, if you wanna use PipeWire in a desktop, we can write basically Python scripts or Rust scripts that base in a much higher level to do basically any kind of policy logic. And with that, you basically can integrate against PipeWire. You basically have all the different levels of integration against PipeWire. So if you just don't wanna use WirePlumber, you just use the PipeWire API to basically do custom policy logic. But if you want more high level, you can use WirePlumber because it has a glib integration. And if you want even more high level, you can use the bindings and basically do PipeWire policy logic using other languages such as Python. So we made several releases of WirePlumber. So we have the 0.1 release, the first one, which was released in July last year, and it was included in the AGL Happy Halibut branch. It's included in that release. Then we had the version 2, the 0.2, which was released in December last year, and it was included in the AGL Happy Hollywood 8.0.5 release, and also the AGL Itchy Fish, which is a 9.0 release of their system. And this month, in June, we released the 0.3 version, which is the first version with desktop support. Now, future, we plan to support, again, the bindings, because at the moment they are not included. So for the next release, we probably will support bindings in other languages. We have to clean the API and make it more stable. We are almost there. We have to improve the documentation. Obviously we have to do more unit tests and examples so that people can start contributing to it. So who started WirePlumber? The author is George. It's sponsored by Collabora. It's welcomed by PipeWire developers. The Git repository is there. It's a free desktop. It's got documentation, finally, and its license is the same as PipeWire. It's an MIT license. Okay, and now we reached the end of the conference. I'm gonna show you a quick demonstration of how to use PipeWire on your desktop.
Okay, so welcome back, and so yeah, in this demonstration, what I wanna show you is how to use PipeWire and WirePlumber on your desktop, which can be quite interesting for some of you if you want to play a little bit with this technology and also have, a better feeling of how an audio server works. So as you can see here, I have on my left terminal the PipeWire project already configured and built, and the same on the right terminal with WirePlumber. So I'm gonna basically run first PipeWire here on the left and then WirePlumber. But before doing that, I wanna open a couple more terminals because I'm gonna use these terminals to run the clients. Now by default, if I just run an audio client here, such as MPlayer, it's going to connect to the default audio server of my distro, which is PulseAudio, and we don't want to do that. We want them to connect to PipeWire. So we are going to run make shell that basically sets a bunch of environment variables, such as the path, which allows you to use the PipeWire tools you just already built, or the LD library path, which points to the build directory of the PipeWire we just built and we are going to run. So make shell allows us to run clients within this shell, and they will automatically connect to PipeWire, which makes very easy to test PipeWire. So I'm going to open a bunch more tabs because we are going to use several clients, and we're going to run make shell on all of them. I think 5 should be enough. So yeah, now once everything is ready, we are gonna run PipeWire with make run, and we are gonna run WirePlumber with the log enabled, so you can see that it's basically doing some stuff. Now you're gonna also see some warning messages such as device being busy, and this is because I'm recording using my microphone, so that device is used by the screen recorder, but it should be fine for what we're going to do, so don't worry too much about that. So everything is running. This is the log of PipeWire, and now we're going to try to play some audio with MPlayer. For example, this one. Now MPlayer by default uses the PulseAudio API. So when I run this, what it's going to do is going to use the libpulse compatibility API of PipeWire, and that library internally, it's going to tell PipeWire that a new client comes in, and it's going to notify the session manager, and the session manager is going to basically create the nodes and link the nodes based on the custom policy. So I run it, and you can hear that music is playing. We can also see some warnings of the PulseAudio compatibility API library. Not all features are implemented yet, but yeah, we can hear music. Now I'm gonna use the PipeWire dot tool to generate a dot graph similar to GStreamer, and we can see that the nodes are basically connected. It's very easy to use. You just do PipeWire dot and then the name of the file where you want the graph to be written, and then we can view the graph with tools such as xdot. So yeah, we can see these here that WirePlumber linked the different nodes. So the green squares here are nodes, the red square are the output ports, and the purple squares are the input ports, and the blue squares are actually the links created by WirePlumber. So this also playback node is actually the M-Player client that has two channels, the left channel and the right channel, and is connected to a converter, and that converter is connected to the default ALSA node, which is my speakers on my laptop. We can actually view more information if we run it with the detail option, and we can see more properties, but it makes the graph much bigger. So yeah, we can see here, for example, that M-Player is this node with this ID. And we can see that the also device that it's using is the hardware 0. So yeah, we can now do more cool stuff. For example, we can use the PulseAudio volume control, power control, and we can see that it's monitoring all the audio being played on my laptop. And we can also change the volume, for example. We can see also some warnings here because not all the compatibility APIs are implemented yet. But yeah, it's working nicely. And we can see then now here, if we run the PipeWire tool, that it's created, WirePlumber created more links. Now all the input nodes, they have a monitor port, and basically the PulseAudio volume control uses those monitor ports and creates these nodes to actually monitor the audio coming out. So that's why we see this here. So yeah, now we can do one more thing, which is running Carla. Carla is an audio plugin host, and here in the patch bay section we can see all the audio stuff that is connected. So M-Player is this also playback node, and we can see that two channels are connected. We can disconnect the left channel, for example, and now only the right channel is playing on my speaker. So if we run the tool again, we can see that, for example, only the right channel is connected. And for example, if I can even connect the right channel, the left channel to the right speaker, and we can see here that M-Player, both channels are connected to the to the right channel of the audio converter. Yeah, we can leave that as it is, and it's back to normal. So yeah, that's all for this demonstration. I hope you enjoyed. Thanks for watching, and see you soon.
And that's all for this session. Please let me know if you have any questions on the chat. I'll be happy to reply. And stay safe. Bye.